Today's talk will be presented by Glyph. He's the founder of the Twisted project, and he will be talking about event-driven architecture. It should be very interesting. Please give a warm applause to Glyph. Thank you, and enjoy the presentation.
Hi, everybody. I'm Glyph, and I've been doing event-driven architecture since I was 8 years old. But so have you, and today you're going to learn that. So that slide, that's not actually what the talk is about. This is what the talk is about. It's event-driven architecture for regular old programmers. Everybody should know how to do it. And since we're at the Python conference, I'm going to take advantage of what folks in the diversity business like to call othering, and I'm going to incite you to hate JavaScript programmers and consider yourself superior to them and be angry that there is a thing that they can do that you can't. So event-driven programming is so easy that even a JavaScript programmer can do it. I didn't put that in the program, but now you know what this is all about. A brief word of warning about this talk. That's kind of an average slide here. I know at a lot of talks, you got your laptop out, you're kind of at work, you're not really paying full attention because you're drifting in and out. I don't mind if you do that, but you may find some of the later parts of the talk like really confusing if you're not actually reading the code along with what I'm saying. So, all right, so things that are hard in JavaScript, since I mentioned JavaScript. There are a lot of things that are surprisingly tricky in JavaScript. If you've ever written a unit test, you know that it's hard to compare the contents of arrays. If you've ever tried to write a compiler with a JavaScript backend, and I know there are at least 2 people in the audience here who have, you know that it's actually really hard to add numbers together because JavaScript doesn't have the notion of an integer. It's really hard to define types every time you need to define a basic class, since either not until recently or not yet, depending on your perspective, JavaScript doesn't have a class keyword. Every time you want to define a new type, you end up reading research papers on self and learning about how the prototype object model works. And finally, loading modules. You have to stick stuff into your HTML and then maybe make some asynchronous requests. And so even just the basics of writing a program are really tough in JavaScript. But what's easy in JavaScript? There are only 2 things that are easy in JavaScript. One is calling functions. It's pretty easy. It's just like Python. You put your parentheses in there and you're good to go. And the other thing is handling events. And the reason that handling events is easy in JavaScript is because there is only one thing that is easy in JavaScript, and it is calling functions. Handling an event is just calling a function. And this whole talk, and basically the last, let's say, 15 years of my career, are all really just making that point. So there are 2 introductions that people generally get to event-driven architecture. The first is Asynchronous IO, and it even sounds hard, right? Asynchronous IO is when you're making a request against an external system where you need a response, and that response is not immediately available, so you need to defer your execution until such time as it is. Sounds hard. Second thing that you might get introduced to event-driven programming through is a clicky button that you click on with your mouse, or your finger even now. Most Python programmers encounter these types of event-driven programming in this order. So it seems really nasty to have to do event-driven I/O, and then they encounter maybe some event-driven UI later on in their experience. But JavaScript programmers get to do it in the easy way. They get to make a button, click on it, and then later learn all the intricacies of coordinating multiple independent agents in a distributed system. So by the time they do the latter, they have a pretty good intuitive sense of how the former works. Now, when I originally thought about doing this talk, I thought that at this point, I would pop up my editor, I'd start doing some live programming. But then, a couple of minutes after that, I remembered something very important, that while I am crazy, I am not stupid, and certainly not stupid enough to try actually live coding on stage. So I'm going to make a deal with you as an audience. I'm going to, if you'll agree to pretend that this sort of stop-motion animation of programming is just as good as doing it live, I will agree not to have long, awkward pauses where I breathe weird and mutter to myself. So, I thought you'd like that deal. It's a pretty good deal for your end. So, all right, so back to the matter at hand. Python programmers often start off with a nice simple bit of code that looks like this. You got your database, you're going to load some data out of it. You got a model that has some behavior for that database. And then you need to load the data out of the database, put it into the model, and then return it. It's incredibly simple, so simple that you probably wouldn't ever actually write this function. Anything in a real program would be more involved, but hopefully it'll be clear what I'm talking about in a moment. Then somebody on your team says, hey, I hear this event-driven thing is really cool. Maybe they're interested in giving it a spin for performance. Maybe they're interested in trying it out for some kind of feature like a chat server. Maybe they just like pulling down new technologies off the shelf and using them. I don't know why, but they start doing this to your code. And they put this kind of junk everywhere. It's like, why do you have to yield that first thing but not the other thing? And what's the decorator doing there? And why can't you just return stuff anymore? And it becomes kind of confusing, even if you're using these nice utility things like twisted inline callbacks or monocle or tornado.gen. Or you could get a function that returns a thing that isn't really a thing yet, and then you have to add callbacks to the thing to tell you when the thing's really there. Then you have to start adding some error handling, and now it doesn't even fit on the slide anymore, so clearly this isn't comprehensible. So the reason that this all seems frustrating and weird is all this code that you're adding. If you're not used to event-driven programming, it's all abstract things talking to other abstract things. You got a web page in your web app. You render your page, it looks a certain way. You got your text and your buttons and your scroll bars or whatever, and then you spend a month retrofitting all of your code to have yields everywhere. And then you look at your page and it looks the same. So why did you do all that stuff? So if any of you went to another talk by a twisted person at this conference, Ashwini's talk yesterday, you'll know that metaphors are bad, and that metaphors serve to do nothing but confuse. So there are no further metaphors in this talk. We're going to do one more here, which isn't really a metaphor, and then we're going to go straight to concrete implementation. If I say button, there's going to be a button on the screen. So event-driven architecture is incredibly simple. It's just saying, when X happens, do Y. It gets tricky because, as I've been saying, the first X is typically something that requires a smaller font to say. And the second X is the thing that you were doing anyway. So I'm going to take you back to the way that I learned event-driven programming when I was 8, which is this much larger font version of the idea. When I do something, when I visibly interact with the system, something happens. I'm going to take you from there to the more complicated thing to show it's really a continuum. It's the same stuff once you understand what handling an event is like on a kind of visceral level. Then all the yields and the callbacks and whatever just make sense and look natural. So, okay, another example. Let's make a button. Thanks to the magic of HTML5, no one can ever tell me that I need to write more code than this to show a button on a web page again. The HTML automatically gets synthesized in the body and the whatever, so hello world. But of course, this is a presentation, so we need to bump the font size up a little bit. Like I said, no metaphors, no abstractions. That's actually what it looks like. It's a button, but when we click it, it doesn't do anything, so not really a program. All right, so we need to handle an event on this button. And all we need to handle that event is to add an attribute to the button. The event we want to handle is a click, so we add an attribute that says onclick. So upon a click, do this. It's a string with some code in it, because that's how JavaScript rolls. And we're using the inner HTML attribute so that I don't have to type hello twice. So there we go, same button, same program, click. Hooray, okay, event-driven programming, thanks for coming everybody, that concludes the talk. But actually what I'm showing here is that two things. Number one, this is an event-driven program, that is really all there is to it, but that pattern, repeated over and over, that's event-driven programming. But I'm actually demonstrating something else here too, which is the JavaScript Alert function, like many things in JavaScript, is terrible. It blocks your whole browser. Now, if we had this alert and then a second alert in the same function, this would stop the whole program until the second one popped up. Nothing else in your JavaScript would be executing. And you can tell that because, and unfortunately I didn't submit my AV form early enough to do this with a sound effect, so I'll have to do it myself. Beep. If you click on that browser window, you will get a system beep. Now, I know that there's probably some Firefox people in the audience who are going to say, not in Firefox, it works better. But in Firefox, you still have the same problem with the JavaScript functions prompt and confirm, so pretend I used one of those instead. So we are now demonstrating a problem, the problem that we were solving with those earlier ugly code examples I was showing you, which is blocking. This is now a blocking program. We're no longer event-driven. Now, under the hood, the browser is doing something event-driven so that my entire computer isn't frozen and I can still click on the OK button. But the program is frozen, and that's irritating to the user, because what if this contains some useful information? If this contains some useful information that I needed in the next step of my program, then the user would have to copy that hello world out of there and then hit OK, and then paste it into the next thing. But even that's depending on their OS, giving them a certain amount of event-drivenness outside of the program. So, back to the drawing board. Let's fix this. And let's forget about JavaScript, because this is PyCon, and I don't know about you, but that one alert function is about as much JS as I can take. So, there are a couple of ways to achieve Python in a browser, because we're going to keep using a browser. Py.js is the one that I happen to choose. It seems to be the most complete. There are a couple others that were honorable mentions, Brython and Sculpt. You can check them out. But Py.js is actually close enough to Python that it demonstrates the points that I was looking to make in this talk better. So let me get you up to speed on what Py.js is. It's both a JavaScript interpreter, it's both a JavaScript compiler. It compiles your Python to JavaScript, as well as a widget toolkit. So it's a library of objects that you can build. So Python is actually doing the job of two languages here. You've got your JavaScript logic and your HTML document elements. We're going to build up a whole app out of these pieces. The things that I've got here are a button, because we want to have a button, a root panel, which is the Py.js way of adding things to the page, and the alert function, which is the exact same alert function we were calling before. So we're going to make it work in the same kind of broken way it was working before we move on to a better way. So, first, whenever you're doing event-driven programming, typically the best place to start is with your event. What is it that you want to actually happen? Don't think about handling it and adding your callbacks. Think about, like, okay, at the end of the day, what are we trying to do? And what we're trying to do is we're trying to put an alert window on the screen right now. So we'll write that function first. The getHTML function here, the method on the button, is just pretty much the same thing as inner HTML. It's just the contents of the button, so I don't have to type hello too many times. So then we make a button. It's typical Python style. You just instantiate the button class with a label. And then, once we've made the button, we add a callback to it. We add a click listener, which is pretty much what it sounds like. Click on the button, this function gets called. And as a potentially interesting twist, this function gets called with the button that was clicked, which is useful for a few reasons we'll see later on. And finally, we actually have to stick that button into the page. So I make a root panel, which is a panel that exists on the web page, and we add the button to it. And just as before, you got to make the font bigger because it's a presentation and you wouldn't be able to see it in the back if I didn't. So, although while HTML can just be opened up in the browser, in the case of Py.js, you need to run a little shell command to generate the HTML that we're going to open up and look at. So there we go again. Not very exciting. It's not quite exactly the same screenshot as before. You can see that the title is slightly different, but it's the same page. And when we click the button, we get the same behavior, including the crummy, you can't actually use the program anymore because it's stuck in the middle of the alert function. So, moving on to fix that. Let's go back to the code. Since we're using Python now, we can use the magic of modularity to change the definition of alert. Instead of in JavaScript, we'd use the magic of monkey patching, so still doable. But so we're going to make an event alert module, which is sort of like alert, but that is event-driven. And here we go. This is a start on the event alert module. We're going to make a function called alert, because that's what it has to be called. We want a label that has the text that we want to show the user, and a button to dismiss the dialog. Then we need to stick the label and the button together. So we make a panel that'll arrange them vertically. And then we will, once again, make a new root panel and add the vertical panel that we just created to the root panel. And that'll put the dialog on the page. And again, gotta up the font size. And actually a couple other things too, because you can't actually tell it's a dialogue if there's no border around it, so I'll put a little border around it. Like I said, no metaphors. If you see it on the page, I typed it in the code. Once again, gotta build it with Py.js. And in this case, Py.js is just a nice little feature of Py.js. It noticed that I imported a module from my main module, so it compiled that one too. And here we go. Hello world again. That same boring button. Click it, and now, look. The browser's not frozen. I can still click on it. Or I could if it weren't just a picture of a web browser. And then I can click it again, and I can get two dialogues up at once, which was previously impossible. So with event-driven programming, you can do things that cannot be done otherwise. And then I got a little carried away. The problem with getting carried away here is that now these buttons don't do anything. I click on the little OKs here, and they just stick around, because we didn't do anything with that button that we had before. So as you can see up there, make the button, do a bunch of style smushing around, but the button doesn't do anything, so let's add a new function. Once again, I'm going to decide what I want to do. What I want to do is I want to remove that panel that I added to the page. When do I want to do it? I want to do it when the button's clicked. So I add a click listener to the button. And once again, got to compile. I'm starting to feel like a C programmer again. Reload the page. Click the button a couple times. We've got our two parallel dialog boxes up. Click on the OK. One of them goes away. Click on the other OK. The other one goes away. And you can do that in any order. In retrospect, I probably should have put numbers into those so you could see that one was going away and not the other. But each one is its own little event-driven universe. You click that OK button, and just that thing goes away, because due to the nature of the way Python allows functions to close over variables, it just magically knows which button that it's, or which panel is associated with which button. So, thus far we have done a dynamic creation and destruction of an arbitrary event source as well as user interaction. But it's, I'm just saying it that way to make it sound exciting, so let's do something more actually interesting logically. So I don't know if you're all familiar with this. Since I learned programming at a really young age, this was a very popular exercise. You write a program like this. This is the number guessing game. I went with the fatalistic version. One version has the user guessing numbers that the computer has, so the user can eventually win. In this version, the user can never win. The user can cheat, or they can lose. But the idea is the computer makes up a number, and then, or the user makes up a number, and the computer guesses it repeatedly, and the user tells the computer whether the computer's number is too high or too low. This slide makes sense? Everybody following along? Show of hands if you got it. All right, cool. So you can run this on the console. It's a really simple program. I think you all expected that that's what the output would be. So Now we're going to rebuild the UI to run in a browser, though. And originally I had tried to write pages and pages of stuff here about why being event-driven is so great and about why all the different reasons you would want to architect it that way. But let me be honest, you just have to run in a browser, so I'm just going to do it because you have to. So back to the editor. So how are we going to do this in an event-driven way without actually stopping to ask the program for input? Those raw input calls kind of expect that nothing else is going to happen. But it's not actually that hard. We'll just kind of turn the program inside out a little bit. So first of all, when the game starts, we have the user, we tell the user what to do. We say, think of a number between 1 and 100. And then we want to let the user guess. So we give an upper bound and a lower bound for the user to guess, and we pass along this game object, which is going to be the way that this game engine interacts with the user. So when the user takes one guess, that there is a function that asks the user via the ask function, or method on the game object, is it the number that we have now guessed? And the user tells us one of these choices, too high, too low, or yes. And then we make the ask method here return something, because we need some way to figure out when the user has answered the question. We need an event that is, this question got answered. And then we have to, once the answer is available, we have to check that the choice that the user made to figure out what to do next. So finally, we check the hint the user's given us. This is mostly just logic. If it's too high, then we set our upper bound. If it's too low, we set our lower bound, and we figure out if the user's cheating, and then give up. And if you'll notice the highlighted line there at the bottom, that's an important line. Once this event is complete, once the user's answered the question, we have to keep playing. This is a pattern you'll encounter over and over again in event-driven programs. One guess is our function we defined on line 4. And if you don't call it again, as you wouldn't if the game were to say to you, no fair, or yay, I got it. If the game was over, you don't try to go again. So rather than looping, you just have to model this problem as what happens next. And if what happens next is you guess again, you just call the guess function again. So to analyze the implicit interface we've defined here, we just have an object with 2 methods, and then one object with 1 method. So we can tell the game to say something to the user, we can ask a question of the user, and we can find out when that question was answered. So let's implement this. Before going to the browser, let's make sure that this doesn't break just doing it on the console, because we should still be able to do everything we were just doing in that little terminal window. So obviously implementing say is pretty easy. You just print out whatever it is the game is asked us to say. Ask is a little bit trickier. And so this is really the most subtle part of the whole presentation here. You need to ask the user something, so you call raw input. And then if the answer is in the list of choices that you've been provided, you're done. But and if it's not in the list of choices, you ask again. But now you have to return something that isn't quite the answer yet. Because if you just return the answer, then you wouldn't be able to turn it into an event that you could handle in the browser. You would just have to pop up a blocking window to say, OK, I can't do anything else until this is done. So what we're going to do is we're going to make a new class, a question, which has that when answered method. And it's still a really simple class. All we do is that we give the answer to that question that we just created. So it already knows the answer when we return it. And then when someone asks for their callback to be called when we answer it, we just call the callback right away. We've got the answer. The question was created with its answer, so no need to delay any further. Finally, we import the other module that we had written, which is the game engine, and we call the guess the number game with our raw input-based game, and there we go. Too high, too low. I don't cheat. I welcome the domination of our computer overlords, so it's just a matter of time. But what we want is this. We want to have a browser window with some buttons in it that represent those choices. So the first thing we have to figure out is what that question class is going to look like now, because we can't just instantiate it with the answer anymore. We don't know that what the answer is going to be ahead of time. So what we do is we instantiate it with nothing, and we're going to assume that some code has asked us for an answer callback. It has given us a callback to call. It has asked to be notified when that answer is going to be ready before the answer is actually available. Because we're going to give back the question right away. The caller is going to get that question object and immediately say, give me a callback. And then later, we're going to come around with an answer when the user actually clicks on something, which in computer time is basically geological eras later, as they're 1 pixel at a time inching their cursor towards the button. In the computer's mind, that was a whole sleep and start saving battery cycle later from when the question was originally asked. So it's later enough. So then we're going to put that question in its own little module, so I have more room for the browser UI generation logic here. So I'm going to make the say method. It's almost as simple as our print method. We just make a label, which is the thing that contains that text, toss it into a root panel, and we're done. Simple enough. Then I'm going to have to write that ask method. And what ask does is, first we make a question, because that's what we need to return. Then I make a horizontal panel that's going to contain all of my choices. I put the question as a label, just some text so the user knows what we're asking. And then each of the buttons in turn. I create an answer button. I'll get to that in a sec. Stick them all into a horizontal panel, so they're one after another. Add that to the page, and then return the question, and then wait for something to happen. But of course, nothing will happen if we don't have an event to handle. So when I make a button, when I make an answer button, what I do is I just instantiate a button. And this uses a shortcut. Instead of doing add click listener, I just pass the click handler right into the button. Because since buttons pretty often want to know when they're clicked, that's a shortcut that PyJS gives you. So when I click on the button, you remember we got the handler gets past the button that was clicked. So we stick a check mark next to the button's name. We do that both to demonstrate how much cool Unicode stuff I know, and also so that you can see which one I clicked on, because my first version I realized you couldn't actually see which button got hit. Finally, we have to import that same game engine that we already implemented. It's exact same logic as the raw input version. And then we fire it up with the browser game that we just instantiated. And instead of running with CPython on the terminal, we're now going to run this code with PyJS in the browser. So now we can play the game. Click on too high, checks off. Check on too low. The computer's fairly predictable in its guessing. So yeah, there you go. That's a dynamically generated user interface that has multiple dynamically generated events in there. And I don't know, some of you who know Twisted will realize that I did this, but in the middle of that, I tricked you into implementing deferreds. If you ever thought deferreds were confusing, now you know they're really simple. It was just that 4-line question class. That's all there is to it.
How do you handle errors? How do you handle errors?
That'll be in next year's talk. So, besides, what error? There's a button. The user doesn't click on it, nothing happened. There's no error yet. Nothing could possibly go wrong. So for my next example, many of you have heard of this game under a different name, rock, paper, scissors. But since it is the ultimate distillation of human conflict, we must use the ultimate distillation of event-driven networking. So I'm going to use Twisted for the networking portions here. In addition to something you might not have heard of, Klein, which is I think that's the maintainer of Klein just said, oh no. If anybody, by the way, wants to design a logo so this slide can be less embarrassing in future presentations, you can get Klein from github.com/twisted/Klein. It's a micro framework for Twisted, which allows you to write code that fits on a slide, as well as a number of other kind of neat things. So now, this here, once again, when you're doing something event-driven, you want to start by thinking of what it is you're trying to do. Start with the logic of your problem. So the logic of the problem of rock, paper, scissors is that player 1 makes a move, player 2 makes a move, they are simultaneously evaluated, and we figure out who won. So right up at the top there, we got our list of the victory that you may achieve. You can, paper can cover rock, rock can break scissors, and scissors can cut paper. So we have a function that'll take two of those strings, player 1's move and player 2's move, and will return a two-tuple of the strings to tell each player. So player 1 gets the first message and player 2 gets the second message. And if you haven't managed to read all the way through this and figure it out yet, you may just have to trust me that this is rock, paper, scissors. So now, the server. So you may be familiar with route syntax from other frameworks, such as probably all of them at this point. What we're going to do is we're going to have a route for /play, which is just
We have to.
time.
Yeah, so the next presenter is coming. So.
All right, well, I'll wrap up quickly. Luckily, I'm pretty close to the end. So, according to me, I still have 10 minutes, but I guess running a little quick. So, we're then we need to host the static content, which is the bits of the Py.js compiled HTML. And we run the server just by running that server file. Then we got to implement the game. I'm going to have to go through this a bit too quickly. Those right there are some awesome Unicode characters that look like rock, paper, and scissors. Taking a turn involves building a panel and then adding it to the page. Each button within that turn will call a click listener, which we dynamically create with a little shortcut for saying stuff. You dynamically create the button which has a callback which does an HTTP request and tells you what you threw. And then when that HTTP request is complete, as you can see the done handler, we make a handler that says done, or whether you've won or lost, and again, and there you go, there's the browser UI for it. And that is actually what it looks like when you run this. So just to sum up real quickly, what is event-driven? An event is just a function that you ask somebody to call. Think of a function. What do you want to happen? The function then gets called when the user clicks a button, when the user answers a question, when the network answers the question, when the network sends some data, when anything happens. The network is just a user on the other side of the planet or on the left side of your screen. So thank you.